Hello everyone. In this video, we will solve some more problems related to block diagram reduction technique. So we come to first question now. We will be given the block diagram in exam like this and we are asked to find the transfer function. I already solved few problems in the previous lecture. The same procedure we follow here. The moment you see the, the block diagram, you find out the loop. Okay. So we have the loop here. So we need to identify the loop as soon as we see the block diagram. So let me name it as L1 and we need to find out the forward pass. So we have this is one forward path and one more forward path is this one. Once we identify the forward paths and loops, we need to write the transfer function. So in numerator, we are going to write the forward path. One forward path, we have only G. So I written here G. In another forward path, okay, we have one. Nothing is there. Okay, that's why I written here one. Or since these two blocks are in parallel, we can add okay G plus 1. That's what I written here G plus 1. In denominator, we start with 1 minus. Already we have minus sign here. Minus into minus plus. In loop, we have G times H. Okay, that thing only written here. Now coming to this question, we didn't see any feedback path. Okay, like we have a feedback path, right? Like that, like this, there is no feedback path. All the paths are forward paths. So we need to find the forward paths. One is the straightforward path here. Okay, and one more is this path. Okay, and one more path is this one. Okay, let me use different pen. Okay, let me use red. So one more is this forward path. So we have three forward paths here. So let me write it. In one forward path, you have one upon s, so 1 over s power 2. In next forward path, we have only 1 by s, so I written here 1 by s. In other forward path, we don't have anything, so only 1. That's why I written here 1. In denominator, we have just 1. Okay, there is only numerator term since there are no feedback paths. Now coming to this question, same way we need to find the forward paths and loops. So there are only two forward paths here. So this is one forward path and this is one more forward path. Okay. Now we need to find the loops. So the first loop is this one. Okay. So let me name it as L1. The next loop is this one. Okay. So let me name it as L2. You, you can get the doubt like why can't this can be a loop? Okay. This can't be a loop because since we have the arrow mark like this. Okay. So the only possible loop is like this only. Okay. And one more loop is this one. This is one more loop. Okay. So let me name it as L3. So we have two forward paths. So this is one forward path. This is one more path, and one more forward path is this one. So this is one more forward path. Okay. So there are three forward paths. So let me erase all these things so that you can see the blocks. Okay. So for the first forward path we have G1, G3, G4. That's why I written here G1, G3, G4. In the next forward path we have G2. Okay, we move like this. G2, G3, G4. So we have G2, G3, G4. And in one more forward path we have like this. Okay, so we have G2 and G4. So I written here G2 and G4. Now coming to loop, in the first loop L1, okay, we have G4 and H1 with negative sign, so overall it become positive. G4 and H1, and in L2 we have G3, G4, H1, H2. So G3, G4, H1, H2, and we have negative sign, so overall it become positive since we multiply with minus sign. And in L3, what we have G1, G3, G4, H1, H2, and H3. So G1, G3, G4, H1, H2, and H3. We have minus sign here, so overall it become positive. Okay, so it is L1, L2, and L3. So this is how we find the overall transfer function for a given block diagram. Okay, thanks for joining. Thank you.